Right now we're going to look at chemical equations from names. So we're going to take this one step forward from where we were. We were looking at formulas, equations where I have wrote out the formulas. Now I'm giving you in name form. So this formula writing that we've been working so hard on is becoming more and more and more important. When we are going to write and balance equations, when we have the names, we need to treat it as two separate parts. Part one is write all my formulas correctly. Okay, so part one, write formulas. I don't want to worry about balancing the equation at all. I just want to write my formulas properly. Then I'm going to balance the equation. They are two separate steps to think about. So magnesium, it's just magnesium, by itself. It's not an ion, it's not anything like that. So if it's just magnesium, it's going to be Mg. So I'm going to use this spot above as sort of my scratch work. Hydrochloric acid, well, that means there's no water. That means it has hydrogen. Okay, so I have H plus 1, and chlorine is Cl minus 1. So it's always good to write these ions and then go down and write our formulas. Produces hydrogen, and hydrogen we know is one of our Hunkelbriefs, and so it's formed a special way. It's diatomic, meaning two together, and it's H2. And then we have magnesium chloride, so we have Mg is plus 2, and Cl is minus 1. Now that I have all of my components, I'm going to go ahead and write my formulas. So I really have Mg plus, and if I write this formula correctly, HCl, which produces H2 plus MgCl2. Okay, the habit is people try to balance the equation as they go along, and it's much easier to write your equations. Now I go back and look. I have one magnesium, I have one magnesium, I have one H, I have two H's, so put 2 here, 2 H's, I have 2 Cl's, and I have 2 Cl's. If your equation does not balance, or it's unable to be balanced, 97% of the time is that you wrote an equation wrong. You wrote one of your formulas wrong. So if I had written this as MgCl, I would never be able to balance this with this H2. It wouldn't work. If it's written correctly, chances are it also balances pretty quickly. Let's take a look at another one. Calcium hydroxide and lithium chloride produce lithium hydroxide and calcium chloride. So calcium hydroxide, so calcium is Ca plus 2, and hydroxide is OH minus 1. Lithium is Li plus 1, and chloride is Cl minus 1. Lithium hydroxide, so Li is plus 1, OH is minus 1. And calcium chloride, I don't like that chloride's written down there, so we're going to treat it all over here, is Ca, come on pen, plus 2, Cl minus 1. So now I'm going to go ahead and write my formulas correctly. So I have Ca parentheses OH2, parentheses important. I have plus 1 and minus 1, so LiCl. I have LiOH plus CaCl2. I can treat hydroxide as one group since I see it on both sides. So I have 2 hydroxides here, so I'm going to go ahead and put 2 here. Now I have 2 lithiums, so I'm going to have 2 lithiums. I have 2 Cl's, I have 2 Cl's, I have 1 Ca, and I have 1 Ca. And that ends up being balanced. Let's take a look at 2 more. So we have aluminum and iron 3 oxide, which produces iron and aluminum oxide. So aluminum is just Al. Iron 3 oxide, that tells me it's Fe plus 3. Oxide is O minus 2. Produces just iron on its own, and then aluminum oxide, Al plus 3, O minus 2. Let me write my formulas. Al plus Fe2O3 yields Fe plus Al2O3. Now I'm going to look at this and say, okay, I need to balance. I have 2 Als, so I'll put 2 here. I have 2 Fe's, so I'll put 2 here. So 2 Als, 2 Als, 2 Fe's, 2 Fe's, 3 O's, 3 O's. Done. Our last one is a combustion reaction. C4H10 is butane, and so it tells us that C4H10. When it's in air, and you will see this a lot, and it's just something that you need to learn. In air means we're adding oxygen. I know it doesn't say combustion of butane plus oxygen, but that's sort of the definition of the word combustion. So in air means you add O2. To produce carbon dioxide, CO2, and water, H2O. So that one's practically ready. C4H10 plus O2 yields CO2 plus H2O. Always leave that oxygen for the end. So I have 4 carbons, so I'm going to put a 4 there. I have 10 hydrogens, so I'm going to put a 5 there. Now look what happens. 4 times 2 gives me 8, but plus another 5, I have 13. I don't have anything, I mean I could do 6.5, but we're not going to do halves. When I run into a situation like that, what that means is I need to double everything. So that means I'm going to put a 2 here. I'm going to double this to an 8. I'm going to double this to a 10. So now I have 2 times 4 are 8, and 8. 2 times 10 or 20, 10 times 2 or 20, and then I have 8 times 2 is 16, plus another 10 is 26, so I have 13 times 2 gives me 26. And that happens with these combustion reactions, where you can have some higher numbers, and sometimes need to go back through and double. You really need to make sure that you know how to write these formulas. One formula written wrong will throw off the whole equation. So when we were working on mastering those, this is why, because we're getting up to this point.